Okay, so we finished problems 1 and 2. Moving on to problem number 3. Uh, Luckily, this one we have components already made for us. So again, you can download those off the Canvas. And those components are in folders for problem number 3. We have all of these parts to add. Again, I would just make sure that the first, part being selected is the bracket itself, or whatever is stationary, whatever will be used as a foundation for your assembly. In this case, it's the bracket. Make sure that one is selected first. That way it can be inputted first and again set as your stationary component. Again, I mean, you could always change it too, right? The first one is always fixed. The following ones are floating. However, if I could just remove that step of having to do that, I already know it's going to be that way, so I might as well set it up to where it helps me out. Let's see, we have our crank over here. We have part of what is this? The piston and the washer. And actually, I think we have 2 washers, if I'm not mistaken. So I'm gonna place one here, and then before I move on, I'm gonna insert a second washer over here, I guess. Why is there? Okay, just two. So let me move this to how you can see it, how it looks like over here. All right, so this is my bracket. First thing I would do is I would set up the washers, right? So I have a washer in between the bracket and the crank, and I also have a washer in between the bracket and what is this called? The cylinder. So to place that washer, I would first add and the order doesn't matter. Like this is how I'm doing it. I would add a concentric mate in between these 2 faces, right? So now these 2 holes are concentric to one another. Now all we have to do is add a coincident mate between the 2 faces. And then that fully defines our washer. Now it looks like these 2 holes are the same measurement. Let me verify that by using my evaluate tab. I find measure. So this hole measures, and are my units supposed to be in inches? Well, yeah, because the parts are in inches. So my hole for the washer measures 0.375 in diameter. I believe that's like 3/8. Now, what does my hole in the bracket measure? Click on measure, click on the hole, click on measure, click on the hole. Why are you not showing up? This hole also measures the same diameter. Okay, so in this case, instead of doing, if we know the holes are the exact same size, right? Instead of doing a concentric mate and a coincident mate, I'm sorry, concentric, this should be concentric. See, it's this face and this edge. So I didn't mean to select the edge of the washer. I meant to select the face. So these 2 are concentric. That's what I meant to do. One concentric mate and one coincident mate between the faces. You can do that, but again, since we know the holes are the exact same size, we can reduce this to one mate, which is simply a coincident mate between the edges. So if we go back to assembly, find our mates, and we mate one edge of the washer with the edge of the hole. Oh, see, in this case, they're different sizes. But no, this should have been coincident. But you see there it's grayed out. The reason it's grayed out is because that you cannot apply that mate. These 2 edges cannot be coincident to one another because they have a different size. So I guess I should have flipped this example around. I didn't realize there were 2 different sizes. But in this case, we do need to have separate, separate mates, right? We need to have one, which is our concentric mate. That's one. And then we need to have a second, which is a coincident between the face of the bracket and the face of the washer. So in this case, again, where they are separate sizes, we need to break that up into two separate mates to make sure it's fully defined. But in this case, we don't need that. And I'll delete these to show you. And go back. So in the case again where they are the exact same size, you can simply use a mate between one edge and another, since they do line up perfectly. Now, if you plan on changing the size of the hole, having this setup where they have two separate mates is better, because then these mates will still apply. But in the case where I would change either size of these holes, then this coincident will no longer apply since they aren't the same, and you'd have to redo it. It's up to you. Just know your options. Okay, so we have our washers mated up. Let's see, we can maybe mate the crank. So we need to have what kind of mate? I would say a concentric mate, first of all. Either to the washer or the bracket. It's up to you. I would do the bracket in this case. So we have concentric mate between those two faces, right? So they're now concentric to one another. But we also need to position this where it needs to be. So in operation, this face would be coincident to this face, right? They're mated up to one another. So if we finish these changes and then check what that looks like now. So now we have a rotational crank, right? And we also have a crank which does not slide out or even move in because its face is coincident with that washer. So that's great. Do the same or a similar thing for the cylinder. So we know this part of the cylinder should be concentric with this hole. All right, so now we have that mate added there. Excuse me. And we also know that this face of the crank needs to be butted up against the washer. Finish those changes, and this is what we have, right? This is the only direction I can move it in. So that's good right there. Now how about the piston? We know one end of the piston needs to be concentric about the crank. Cool. So now we also know that it needs to be mated up against it because although they are concentric, it still does this. So I would say let's add a coincident mate between this space and this space. So now it doesn't move anywhere, does not slide out. Now those two faces are mated up with one another. So this end is properly constrained. Can we constrain the cylinder with the piston, right? So a mate I would add there would be another concentric mate. I would make any one of these rings or any one of these faces concentric to the piston itself or to the cylinder itself. So I don't know, pick anyone, doesn't matter. I'll choose the middle one. This mate over defines. So this happens whenever you over define the assembly, right? And it asks you if you want to continue with this mate, you'll have to break others to satisfy it, or you can simply add this mate and over define the assembly. I want to see, I think I know which one it's going to be. I think this would interfere with the mate between these two components, right? Which would be, if we look, would be the most recent one we made. I think this mate interferes with these two being concentric to one another. So what I'll do there, just to verify, if I delete this mate, if I deleted it now, right? So these two are free to rotate. And then I go back and try to add that concentric mate. between the cylinder and the piston. All right, so now they're concentric with one another. You can see that when those two are concentric, the piston itself is not mated up against the face of the crank. So that was our problem there. It could not satisfy both of those mates at the same time. So this is, I believe we're getting close. Let's rotate the crank now. Cool. The crank operates as it should. So we can rotate it at the piston end. So this is still possible, right? This also satisfies the mates. So can we constrain this, say, in a way where the piston cannot be removed from I'm blanking out on names here, from the cylinder. What I would do there, I want to find what is the top dead center of this piston, meaning at what point are these two faces, at what point is the piston at top dead center? Trying to think of a way I can place it at top dead center. Top dead center would occur, I mean, it's somewhere in this range. Is there a way I can make it at TDC? Let me think about this for a second. I'm gonna place this at TDC. All right, so I've had a second to think about this. Um, I think in this case, it just happens to work out where TDC is wherever these two faces are lined up with each other. So if I had a coincident mate between those two faces, this is the top dead center. Now, this isn't necessarily the case in all engines. This is just how it worked out in this case. But it's fine for now. This will work for us in terms of this assignment. So at this very point, that's the most it can travel. I want to add uh, a limit mate to make this the most it can travel, so it doesn't pop out. However, we could also just delete this, right? Since we're only using it to check where TDC is at, top dead center. If we delete it, it's not going to move, but then that constraint no longer applies. That mate no longer applies. So what I could do is I could just fix one of the components in the meanwhile, so it doesn't move on us. While we add, I don't know, but then it would have to. Okay, leave it floating. It's fine. Let's add this mate, but let's just be really careful not to move this anywhere. But I want to do a distance mate. Let's say between, and this could be applied in many different places. It doesn't necessarily have to be where I'm applying it to. But in this case, let's say we could do an advanced mate, right? An advanced distance mate between these two faces. I'm afraid if I add this, it's going to move it somewhere. Let's do this. Let's fix this for now. Add my mate. an advanced distance mate between these two faces. So I know if they're currently collinear, not concentric, not collinear. If they're currently coincident with each other, then this distance at this very moment between these two faces should be zero. Let's type in, well, it can't move regardless. This should be zero. So I'm going to put its current position at zero. And let's say as the piston travels in the cylinder, this value is going to get greater as these two faces uh, move apart from one another. So this should be my minimum, right? Should not go any less than this. My maximum, I don't know what it quite is yet, but I do need to set a range for this to move. See, this is in millimeters. I don't know this distance yet. Can I just leave this as is for now? Hopefully, fine. It's a little upset, but can leave it as is. I want to check the distance with my evaluate tool again between what would be the max distance between this face, right? The face of the piston. I'm sorry, not the face of the piston. Between not that either. I want to do the face. What's the distance between this face and this face? It will give me a normal distance if I click on those two faces, which is in purple here, 1.375. That would be the normal distance, right? Or the straight line distance between those two faces. So that would be a good starting point, 1.375. Let me go back into my distance mate. Let me change my max value. So, nope, I don't want that. Let me close that before I make any changes. Okay, this is an advanced distance mate. Let's do between 0 and 1.375. Hit OK. So now I should be able to move. Oh, something's fixed. That was fixed. Now it's floating. Now this should be able to move. This cannot go past in this direction. But I also want to check if it's possible. See if we can't make suppress this. Now this might work as is, right? It might do exactly as it should, and I can verify that, right? Not make this transparent. So if I rotate the crank, it operates as it should. It's fine. Let's say if I rotate the cylinder, however, it still does this. So put that back in there. So I need to specify the distance. The max distance can be greater than 1.375. Or no, it can't be greater than. I need to find my max distance essentially. So where is this? Not at TDC, but at bottom dead center. Ah, I see. The piston travels further than I thought it would have. So then the real question is, and it looks like it already has kind of a sleeve there. What is the distance between the mate that I added whenever, go back to assembly, whenever this face of the piston is, it's a little tricky here. Nope. It's gonna be tricky to select that. Okay, what if instead of transparent, what if I turn this, can I do a section view? Don't crash on me. Stay tuned to find out what happens. No. So what happened there is Zoom crashed, not Zoom, SolidWorks crashed, so I had to go back and start from the beginning. So again, remember, please do save your work often. It's a headache whenever you lose all your progress. Not fun. Um, so what I want to do is I want to open up this individual component, right? Just a crank alone. I want to turn this into a section view. Oh, come on. Well, the good thing is I saved the work for my assembly. So none of my work is gone. But this happens often whenever your computer is running out of memory, right? When if you have a lower end computer and you're overloading it with work, can't handle that, it'll just crash. So either get a decent computer or and even now, like I've minimized, this is the minimum amount of stuff that I need to record these videos, but I also have a setting where I have a simplified interface, which makes it run smoother for lower end computers. That's also why I kind of, remove the shadows, make it wide, try to make this as simple for the computer as possible to run. But it's very surprising to me that it can't even do a simple, very simple section view. Let me try to make it easier on it. Let me close this momentarily, save my work. Let me just try a section view on this alone. That's not too much to ask. Okay, this is what I want. Gonna save this. Let me close it for now. Let me open up the assembly. Hopefully the part is a section view in here now. It's not. All right, let's try this again. Please don't crash. Section view. Section view A. Can I select this component? Yes, section by component. Transparent section system, blah, 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 blah. Can I just select the plane? Plane about axis. Problem here is the planes that I have don't necessarily match up with the planes in the component for the assembly. Let's see, can I do zonal intersection? I'm not sure what that means. Could I even change the plane that I'm referring to? Um, section one. What about if I do section two? Right plane. But again, that's not what I'm looking for. Trying to see if I can do a section of this by selecting not just the plane alone, but the component. Reference plane, selected plane. Can I do, can I change the plane to cylinder, please? Thank you. The component itself is fine. I don't think I have to do the whole thing. So let me, can I, what is this, section view one? Is there a way to change? I mean, it's fine as it is. Yeah, it's fine. That's fine. As long as it works. All right. Don't break. So I did a section view. I just want to see the internal workings of this part. So please don't crash. Okay, we have our limit distance. It's broken. All right, we have our limit distance. We have our minimum value set. I want to know what that maximum value would be. So in this case, that maximum value would be whenever this space is touching, and the bottom of the cylinder is touching the bottom of the piston. So again, I could use mates for references, right? I want to know when these two are touching. Easiest way for me to do that is just to add that mate. Let's make these coincident to each other if we can, please. All right, it's been ever satisfied. Okay, so it can't. They can't touch, meaning it probably doesn't reach that whenever. Unless these are something fixed. Something fixed. Why do I have no articulation here? Is it because of the section view? Can I not rotate during the section view? No, I can. Okay. It just might be a little bit slow to do so. Computer's struggling with this. Come on, buddy. Oh, is it because is this the maximum limit? Maybe it is. Let's change this to like 2, a larger value. That might have been my issue. It was. Okay, cool. So in that case, now can I? Sweet. All right. What is this distance, right? So let's just finish this, mate. Again, you can use them just for reference, so you could delete it after, right? I want to know what the distance is between these two whenever they're contacting each other, right? This cannot go further than that. 1.75. So that should be my max value. So if I change this to 1.75, now hopefully the piston cannot go further than this in this direction, and it cannot pop out. Hopefully. Okay, let me turn off my section view to help the computer out there. Um, so nothing's fixed. All right, if I rotate this from the crank, cool, it works as it should. Let's if I rotate this from the cylinder, can it pop out at all? It looks like it cannot. Cool. All right, this is set up properly. This is problem 3 assembly. I just did want to note for the assemblies that you do, sorry, that you do, um, you can't or you have to submit not only the assembly file, but you also have to submit the part files that are included in that assembly. So that's the reason for me why I saved my assembly under the same folder where I have my parts. And the reason for that is, let's just say you submitted the assembly alone. Well, the assembly file is referencing those part files. So those part files aren't there, or that path isn't there, then it has nothing to reference. It has nothing to show. You cannot turn in an assembly alone. Whenever you submit anything within assembly for this class, a homework assignment, an exam, whatever, anytime you submit assembly, include the components that are being used in that assembly. So this assembly was made, and also you can change the view of this. If you do view, like large icons, that way you can see, you have like a better preview. If this is the assembly I made, I need to make sure the referenced components are included with that submission. That way, whoever's downloading it can download the entire folder, right? Since you downloaded this folder, you can now use this as your own. You downloaded this folder. This is not for you. Turn that in altogether, which I should have shown you earlier. I just skipped my mind. This problem 1 file should be in the same folder as uh, where your parts are at. And then you would turn this in as your own work, right? Because this is a copy of something that you downloaded. So just make sure you turn in your parts with your assembly. But again, that was, let's see, was problem number 3, properly constrained, and that's it. Thank you.